This is Scottish Draft doing some math. Today we'll be working on some geometric symmetry. So, symmetry is the property of a shape that allows it to be carried onto itself by reflection or rotation. You probably heard this word, like say we have a triangle here. And if I drew this correctly, let's do it this way. Now, if I drew this perfectly, the left would look like the right, which would just be cut in half. That would be considered symmetry. Line symmetry is a figure in the plane that has line symmetry. If a figure could be mapped onto itself by a line of reflection. So that's basically what I did. I cut it in half. I will go more examples below. So let's ignore this. So line symmetry. So we have a heart here. We only have one line of reflection because the left looks like the right. If we tried a horizontal cut, the upward portion does not look like the downward portion. So this actually only has one line of reflection. This A has one line of reflection, but this clover here, this 1, 2, 3, 4, 5, 6, 7, 8 clover, actually has 4 lines of reflection. So you can cut it in half this way. You can cut it in half that way, or that way. And if you do that, the one half will always look like the other half. Triangle has 3 lines of reflection, or rather, an equilateral triangle has 3 lines of reflection, and each of them are down by its vertices, or its edges. So this edge, this point here, this corner point here, this edge, and then this edge right here. So 3 lines of reflection. Here's some examples of no lines of symmetry. So the Z shape here, they try to cut that down, but that does not work. The left does not look like the right because of all these curves. As you can see, this curve here is much larger than that smaller curve up there. They tried this triangle. No matter how you cut it, the left does not look like the right. Same thing here. It kind of looks like it, but it's not. And then a water drop. No lines of symmetry. Alright, let's look at, and don't worry about these other vocabulary words, I'll go over them as we go through these examples. Alright, line symmetry. Look at the shape and the dotted line. Use patty paper. Well, so patty paper is just like, it's like this very thin paper, and lets you kind of see the folds. But don't worry about that. But basically, imagine, look at the shape and the dotted line. Like imagine, you might see this in your homework too. Don't use patty paper. Just imagine folding it across that fold there. Will everything line up? So I'm going to fold this triangle in half. Is there any edges sticking out, or is it like a perfect fold? And this is, yes, there would be this is a correct line of reflection. Number 2, does the bottom look like the top? Now, if this is drawn perfectly, then yes. You can fold that onto the other side. Number 3, no, you can't. Because if you imagine folding this edge here will be sticking out. It won't fully overlap. Number 4, no, the top does not look like the bottom. Number 5, yes, the left looks like the right. Number 6, you can do this on a sheet of paper, but when you try to fold like this corner will not be in that corner when you fold it over. And same thing here. Or actually, yeah. Actually, this one should be yes, I believe. Take a sheet of paper. Just making sure myself. Let's just pause the video really quick. Okay, I just checked. If you try to fold it that way, it does not work. And then, but this one, you do. Let's see, what's next? So no, there is no lines of reflection here, but boom, 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 boom. You could cut it in half that way. I mean, you could have folded over those 2 lines. So next, rotational symmetry. So how rotational symmetry, how that works is you basically start at the center and then you rotate the object. So think of this as a block, or like kind of like a faucet. Like usually faucets are round. Maybe like this one, but just imagine grabbing this object and you're just rotating it. So here's my center. Does it have rotational symmetry? Does it mean, so as you rotate it, if you spin it around, do you get, if you spin it around, do you get the same exact shape you started with? So if you move this 120 degrees, or I mean if you just turn this piece here will be down here, and that piece will go down there, and that piece will go down there, and you start off with your original picture. So yes, this does have rotational symmetry. This one does not. As we rotate this around, this point here will be, this is sticking to the left. If I rotate it up, it will be sticking up here. If I rotate it to the right, sticking down there or down below. So it does not look like the original picture, no matter how you rotate it, unless you rotate it all the way around. Same thing here. This gap is going to be pointing downwards, left, up, as we rotate it around. The heart, these 2 bumps. So these bumps are up here. If I rotate it around, the bumps will be right here. So on and so forth. But yes, this one, you rotate it around about 90 degrees. It'll look exactly like itself. Number 6, no. Yes, on the clover. You can spin that around quite a few times. And same with the rectangle. Now the rectangle, if you rotate it this way, does not look like the original picture, but when you go upside down, it's the same. Okay, so with rotational symmetry, there's also an order. And it basically tells you, if you rotate it, how many times can you get itself before you reach 300 60 degrees. Or, like, when you rotate it, how many times do you see the original picture or the original position? So if I try to flip this lightning bolt around, it has no rotational symmetry, so it's order 1. The only way to get this original picture is by going in a full circle. So how do we get this S? We can flip it upside down and get the same picture. But we can't put it on its side, we can't put it on a diagonal. That will not look like the original position. So this is order 2. This faucet looking thing, we can rotate it about 3 times. And then this 4 times. Because this spot can go here, and it would look like the original picture. And then here, look like the original picture, and then here, look like the original picture. Alright, let's try some of these out. So 9, I can flip this upside down, but I can't point it left or right or diagonally, so this is order 2. This one is actually order 1 because this is not an equilateral triangle. All the sides are not the same. This one's sticking out, this top part here. So when I rotate this around, it'll be out here instead of there. So this is order 1. The only way to get the original picture is by spinning it is 360 degrees. Here, if I spin it over here, it'll land here, 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 here. So that's order 5. This is order 4. This @ symbol is order 1, only 360 degrees. 2 for this rectangle. If it was a square, then it would be 4. The sun here, and let's assume that all these segments are the same length. Then we got 8. Once again, 2 over here. So vertical, nope. But if I flip it over to the other side, it looks like that. Same thing. Okay, degree of rotation. So how do we figure out the degree of rotation? I will show you how through example. So notice here, so notice that this is order 2. And it's a 180 degree rotation. This is order degree 4. Because I can spin it around 4 times and it'll look the same. Or 4 different ways. And this is 120. This is order 3. And then this is order 5. 1, 2, 3, 4, 5. To get 180 degrees, I'm going to take my 360 and divide it by my order. So that's 180 degrees. 360 divided by 4 is my 90 degrees. 360 divided by 3 is 120. And this is 360 divided by 5, which is 72. So that's where they got these degrees from, based on the order. So we have 1, 2, 3, 4, 5, 6. 6 sides. 1, 2, 3, 4, 5, 6. Now let's assume that this is perfect, that all the sides are the same. That means we can rotate this around 6 times, or I can rotate this around 6 times before reaching a full circle, and it'll look exactly the same during these 6 positions. So I'll take 360 divided by 6. And that'll give me a 60 degree. So from here to here is a 60 degree turn. Smiley face. This is order 1. There's only one way to spin it around and get to get itself, and that's 360 degrees. Here is 180 degrees, order 2. And then this one is 120 degrees because this is order 3. Alright, good luck on your Yep, good luck on your homework. Have a good day.